Hello again. Back with a new video. Again, sorry about the audio of last time. I had a rough few days. I didn't want to do it again. But let's continue. I hope all is good now. Last time we ended up doing the smooth speed acceleration deceleration of a motor. Today I want to run two motors from a single controller or a single microcontroller. So for that, I've wired this up. There are now two motor controllers. There's also the rotary knob. It's not being used now. So identical wiring. One of is the TMC smooth motor controller, and one is the A88 something. So the simpler one. I only had one of the TMCs, so they're slightly different, but they should be pin compatible. So two identical motors as well. Put on a bit of a propeller on the other one as well, so we can see what's happening. So that's the wiring. Nothing exciting there. So let's get to the coding. I need to actually connect my laptop then. Apologies. Takes a second. Here we go. So this is where we ended up. We had the single smooth running engine on the controlled by the form endpoint. So a few things we need to do to generalize that to control more than one. To start with, on the side of the web the web API. Sorry for all the scrolling. So we are here in the web task. We end up doing serve with state, and the state now is one single sender. So that's not really gonna work because we need to at least have more than one sender. So in order to do that, I propose to where's the move command, to start a struct that just app state that models whatever we need it to model, and that will contain let's keep it sized. So I'll take this as an example, and we create an array of we'll create an array of senders. So let's say here senders equals array of this, not a channel but a sender. Copied it to get all the things right. Static, I suppose, and with 2 in this case. So now we can still use this as a sized, and we don't need an allocator. All right, so we have to, this struct now. So let's replace it in the right here. So here we have now a sender static yada, and we replace that with app state. And that means that this is called app state now. Something like that. Then we can say app state borrow, and then we say senders. And for now, let's take the first one and send the payload and await. Right, so now we have a bit more general case. We need to make sure that we pass in here as well. When you create the state, we also create the app state. I think what do we need to put in here? Let's call it senders. So we put in the array, and then we add it here, senders as an array as well. And I think then this is correct. Yeah, now we have app state, only we need to fix the invocation point. So in the main function where we here we need to create an array out of it. So we'll get to that. First, we will also need to create two motor channels and two motor receivers, right? Because that's kind of the point. It is a little bit trickier than you might think, though. First of all, if you look at the signature of the motor function, I'll call it function for now, it has hard-coded GPIO pins in it, 1 and 2, and the other one is on 6 and 7. So they have a different signature. So we don't really want that, because we don't want to copy paste the whole function. Second thing is that Embassy executed tasks, this macro, indicates that this is not really a function. It's not really a function you can call whenever you want. It is statically allocated, so on startup all these tasks get created, and at the spawn point they get started. But if you want to have two motor tasks, you have to create two motor tasks. So we'll need to deal with that. And it all does that to not have to rely on an allocator. So that if you have like the number of tasks is fixed. So what do we need? First of all, let's make this motor function a specific one, and remove everything that's generic. So this, let's call this the motor 1 with GPIO 1 and 2. Basically what we already had. And then this function will not be a task, it will just be a function we can call, and we can give some generic variables. So let's make it generic for those two pins. Those pins we call D for direction and S for step. And we'll just remove those types here. And S for step. And then, oh, that's the wrong one. That's done. So this will be D and S. And we will restrict those types. And the D will be direction, so that's an output pin. And S will be a toggleable output pin. So these traits describe something that a pin is supposed to be able to do. And in this case, the direction, we're going to set it high or low based on the direction. Then toggle, we're going to just call toggle. So just change. All right, that seemed to appease the compiler. Let's move on. We are creating a stepper here, this object, but that has the exact same problem, right? So we need to make that generic as well. Direction and step. Let's see if I can get it all to work. So we need to repeat that. This one needs to be generic as well. With a direction and step. to introduce them here as well. And then, oh yeah, that makes more sense. Okay, same here. D and S. Probably need to add the type constraints. Yes, exactly. So D is an output pin and S is a toggleable output pin. Okay, so that seemed to make everything happy over here and here as well. So now we should be able to invoke motor here with a wait, of course. And that should do it. So this is boilerplate that will just need to accept that we need to create a task for every motor, but basically 3 lines of code, or 2 sort of, is not the biggest deal. So we can just create a motor 2 as well, and that will have 6 and 7. Oh, what happened there? Okay. So, well, here we need to fix some things still. So this needs to point to motor 1 in this case. And motor 2 as well. 7 and 6 and 7. I need to dig those pins up. 6 and 7. And here as well, 6 and 7. Alright, so that part, the motors seem to be set up. Now we need to deal with the channels, right? Because we have a channel here for let's call it motor channel 1, and let's create another one for motor 2. I mean, we can inline that, but and then let's say motor channels. We're gonna make the array we wanted, and we put in motor channel 1 and 2. Alright, let's check the type. So we see there's an array of 2 of those channels. No, let's create an array of the senders. Yeah, because that's what we need to pass to the web API run, right? They want just the senders. So like this, we have an array of 2 senders. Okay, let's fix this again. So this is motor channel 1 and motor channel 2. And here we're gonna pass in, what did we want to pass in? Did we want to pass in, yeah, the senders, right? I had the array there. So the senders. Yeah, that name doesn't make sense. Motor senders. And we put that here. Okay. So now the web task has access to an array of senders. And then we're gonna, before we start everything, we create the app state with the senders in it. And then we can serve requests. However, we still need to do something with to access, to be able to address a motor, right? We want to send it to a command to one motor or the other. So to do that, we can use a pattern that goes something like that. Wait, let me check my notes. So instead of just the path, let's create a little bit better path, /command, and we can add to it a path segment. So let's create it. We have to create a tuple, and then we say parse path segment, and that will. So we can do /commands and / and then something that will get parsed here and then passed into the get function. This is something we'll still need to use Turbofish to define the type, and that's an usize in this case. And we need to update our get function. No, that one. The get root, I mean. So this is the endpoint that forms our command. We have the form that gets posted to the, or it's not a post, but it gets uploaded from the client, and the app state that we did before. So let's add a parameter here, and let's call it something like motor index of type usize. So that's in this case that would be 0 or 1, 0 for motor 1 and 1 for motor 2, something like that. And then we can use that to address in our index of senders to which sender to send it. Okay, so as far as I can tell, aside from some unused warnings, I think compiler says okay. Let us do this. So let's see if we can flash it. Put on power. And then we'll see. So in our Postman, we will need to go to command and then 0, for example. That should go to the first motor, and /1 should go to the second. And then we can still control the distance, speed, etc. I do expect the motors to behave a little bit differently. So this one is up now. So let's see if it works at all. Look at that. One is running for a bit, and then it will slow down at some point. 20,000 is quite a bit. All right, so let's do that again, and then straight afterwards see if we can send one to the other one as well. Yeah, so first of all, we can see that both of them work at both of them can run at the same time. Also that this one runs quite a bit quicker. I think this controller has a lot fewer steps per rotation. The other, because the smooth one can really interpolate a lot. So the same values here result in quite a different response to the motor. Also, I have found out that if I leave it powered on, it gets pretty warm, that motor, and the other one does not. I'm not sure what's the difference there, but maybe that's just a matter of tuning the current a little bit. So, but yeah, it's pretty nice. So we didn't really make the code a whole lot more complicated, if I may say so myself. This one added some indirection, but it's not terrible. We still used static dispatch, so no overhead there. We do have to create 2 tasks instead of 1, but it doesn't really create code because you could make this code generic over both. And yeah, it also shows the power of having the channels, right? Because we can still have what we did before with the first one, that you can say like, I'm gonna spin this way, and then we're gonna spin this way, and then we're gonna spin the other one this way, and then we're gonna spin the other one this way. So and all this parallelism doesn't really cost any complexity in the code. And I think that's really powerful because yeah, any code is, if the case is simple enough, the code is simple. But the trick is to get it bearable for more complex things, and I think this one scales quite nicely. So it's a pretty short one, I feel, today, but a nice one. So I hope the audio is good, seriously. And yeah, like always, leave a like if you know other people who are interested, or if you have something you want to do on the channel, leave a comment or just reach out to me. I'm always happy to talk Rust, embedded, whatever. And take care, everybody. See you next time.